Welcome, my project is called Finder Drone and it's an AI powered drone that finds pets, people or whatever. Okay, this is a summarized version of the presentation. You can check the extended one in the description, and that's very long, around 2 hours. Okay. Okay, let's begin. Okay, the motivation for this started with something that happened in real life. Someone close to me lost her cat, and I had the idea to search it with a drone, and I borrowed one from a friend, and we recorded the surrounding area, and then checked the video manually. And unfortunately, we couldn't find the cat, but that idea was in my mind until now. Well, I said if I'm able to get a drone when the project showcase challenge was announced, I would love to do it. Okay, and this does not only is not only for cats and all that. So this core idea has many appliances. For example, we can find lost people, or that it can be in disasters, or well, there are many appliances. So this idea can be applied to many things. Okay, the objectives are to program an autonomous drone that finds and tracks a specific subject from aerial images on real time. But the use case for this project will be to find a specific cat or any cat, both scenarios, based on a video feed. The project must be also extensible to find people or other kind of subjects. Then we have to also use the techniques learned in the course. And finally, to achieve a working demo. We don't want to just do a theoretical work, but we want to work it in practice. Okay, then the scope for the project, it will run in a small non-industrial drone, this DJI Tello drone, which is, as you can see, is very small. The project will run detected toy and real cats from aerial view, and it will run on a small delimited area. The drone will fly around 2 meters high, well, due to limitations of the drone and all that. And as we said, it will find any cat or a specific cat based on a video feed. And finally, that the training will be done in a federated way using Raspberry Pis. Okay. The basic idea was, assume this is an aerial view, was to have the drone to fly in a spiral until it finds the target. Let's say it's a blue cat, so it would go in a spiral, ignore the ball, and then ignore the green cat, and it would, until it finds the blue cat. So that was the idea, but well, it seemed easy. So I said if I had a good cat detector, this looks easy, and maybe we can work. And I underestimated it so much. I was so wrong, because that's in theory. It's easy to underestimate in theory. Things are much easier, but in practice is what is very hard. So. So from all the effort taken, the 10% was in the theoretical idea, and the 90% was implementing it for real. Okay, here we have the same in a 3D view. Okay, and well, we don't want only for the drone only to say if it found an object, but also to tell us where exactly it is in the coordinates. Okay, the overview, we have three components. One is the object detector, the other is the drone autonomous flying, and the cat classifier. The detector only tells us where there are cats in an image, and the classifier will tell us which cat is the one we found. Okay, let's see the object detector. Okay, well, the first component, it detects the coordinates of any cat found on an image. We use the faster RCNN model. It's an object detector, and we customized it to handle these object detectors by default. They are trained with photos from the front, but in aerial views we could have something different, maybe this like this, but flipped vertically. So we were able to solve it in a way that didn't affect performance. You can check it in the extended version. and we called it faster RCN and fleet mode. Okay, so we have the object detector done. Okay, as we said in the flipped image, well, this modified detector works with this, unlike the conventional ones. Okay. Okay, that issue was solved. Then the next issue was with, the next component is a drone on autonomous flying. Okay, so the drone has to fly in a program path that we are going to call mission, and during that mission, it has to be running also the AI and maybe adapt its flight based on the AI results. Okay. And but the drone I got didn't have the features I needed. This was a surprise. This was disappointing. You can check in the extended presentation and unboxing I'm doing. And okay, why? Because look at the drone, and it has the camera in the front. And for aerial views, I need a camera in the back. Sorry, to the bottom to take aerial views. So I was very disappointed, but I had an idea to use to reflect it with a mirror. So I had the idea to get a dentist mirror like this, and to place it here, and surprisingly it worked. So this was the final result. It took me several hours to accomplish this, but I used elastic bands, cardboard, and a mirror, and you can see another view. And yeah, and it reflected the image. I had to digitally flip it, but it wasn't a problem, and it worked. The only drawback was that the image quality, it dropped. It reduced considerably. But it was good enough for the project. We adapted to it as well. Okay. Then the other issue, so the camera wasn't the only issue. The other one was the erratic flight. Okay, so the drone, unfortunately, by using its ADK and all that, it didn't obey. Let's say you told it, go 1 meter forward, and it sometimes did 1.3 meters, other times 0.8. So it was very erratic. Also the speed. So consider this was supposed to be a spiral, and the drone did something like this, very, very erratic. Well, this is exaggerated, but for you to get an idea. And the same in a sequential flight, so it was or crashing to the walls or missing important parts. Yeah, it was terrific. So I had an idea to use visual brakes because the drone it sees well. So I had an idea to do some visual brakes. So I made this from wood, some squares of wood with electrical tape. And they needed some modifications. My first idea was doing with some coordinates. We can check this in the extended presentation. And these are the wooden pieces. Okay, but that idea wasn't enough, so I had to add these small stitches that tell the direction of the brake and where it has to push. And here's what I did with OpenCV. Some transformations and detections. Okay, and this was the final result. So it square is detected, and it tells where to push the drone. In this example, it would push it in diagonal to the right and backwards. Okay, and there's a demo of that working in the extended version, here. Let me introduce you to Whiskey. This is a toy cat. He's going to help us. His name is because he likes Whiskas, by the way. Okay, so we're going to join what they did with the object detector initially, with the cat detector with the drone flight. And okay, let's see the demo. We are running the program. Okay. With a sequential mission, and let's see if the drone finds Whiskey. Okay, let me read a little more here. Okay, and let's take off. Okay, and start the autopilot. Okay, it's going well. Here you can see the project output, detecting the squares. Awesome. Awesome finding. Let me show another perspective. It almost went out. Okay, we found it. Let me show you. Yeah, it's been found. This is awesome. Okay, success. Okay, that demo worked very well. And now the third component of our project is the cat classifier. Okay. Okay, so first let's meet the cats. First we have Whiskey. Well, you already know him. Then Juana, a real cat. Yes, she has only one eye. We adopted her that way, but now she's very happy. And then Lily, a precious cat, and Yayo. It's a cat replica, but it's very, very small. Now we are going to create the data set based on a video. So this is going to be for Lily. So here I have the video. It's the one we are going to use. Okay, we are filming here. What we are going to do is we're going to check each frame and then run the cat detector and crop the image of the cat on each frame and then save each image. Here I have it inside dataset, valid, train and test. So with 60% probability this will go here in Lily, train Lily. Okay. Okay, let's run it. It's running and we'll see a preview of the progress. Okay, here we can see it's checking each frame and cropping with the cat detections. Okay, let me show you. For example, here they are. Okay, and that's it. That's how we generate our dataset from cat videos. Okay. Then, well, this is the ResNet 50 model we are going to use. I'm not going to explain it. And okay, and here, okay, this is a very simplified version. We get an image as input. Then we have many layers, 2048 outputs before the last layer, which is called FC, and then 1000 outputs. So we didn't do a traditional transfer learning. It's explained better in the extended version, but what we did is we replaced this layer with an identity layer that it's basically whatever comes in goes out. Okay, and we did and then we plugged our model. So instead of putting it inside as traditionally, we put it outside. Why we did this? Because having them decoupled allowed us to train this simple model, which just gets one tensor as input, and get the output here. Well, it's missing the 4 outputs here, and then we can well, this ResNet doesn't need training, but we can do the inference with CUDA or with your CPU. So this can be done locally and this in a federated way, because ResNet 50 is heavy, many computations and all that. So having all this in a monolithic way as traditional, well, it would have hurt performance. The Raspberry Pis would have run for days maybe or several hours, but having this locally and this federated worked great in less than an hour. Okay, so let's see briefly how the training was. Okay, here we have Raspberry 1, which is IP48, and Raspberry 2, IP49, and they are called Raspberry 1 or Raspberry 2. Very creative. Okay, and here I have them in the 2 remote consoles. So I'm going to start. This is the Raspberry 1, I'm going to IP48. I'm going to start it with the verbose option so we can see what's happening, and enter, and also for the second one. Okay, so training has finished. Okay, let's plot. Okay, I like this. Okay, here we have our training loss, validation loss. I think maybe a good fit could be here or here. Okay, we'll see. Okay, this is clearly Yayo. Let's see, prediction Yayo. That's very good. Expected Yayo. Okay, that was training. You can see a deeper explanation in the extended presentation. And now training has been done, and we have the model stored in a file, and so we can use it in the application. Okay, now it's time to join what we did so far. Well, we're going to join the detector and the classifier we did in a MyCat detection model that's in the code. Okay, now the demo we're going to do is where we are going to detect Lily. Well, we tried with Lily and Juani, but the drone is too noisy. It freaks them out. So that was a failed attempt, and my last resort was well, was to hold the drone with my hands, so it wasn't noisy, and do that demo with Lily. I did that because well, I really wanted to test it with real cats, because that's the final purpose. And yeah, and the only way to not freak it out was by turning off the motor. So we ran the same program, but with the motors turned off. But all the classifier and all that, it's running from the real program. Only the motors are off. Okay, let's see that demo. Okay, so the detector and classifier work with real cats. I am very happy. But well, unfortunately, we had to turn off the motor, so we couldn't integrate that with the drone flight. But now it's time to putting it all together in a final demo. Okay, in this final demo, we are going to have the drone here, and it will fly well sequentially. And the target is to find whiskey, okay? But it will, in the middle, he will find Yayo, and now I modified the program to show a rectangle around him. And so he will be detected, but will be ignored, because he's not the target. And there will be many other objects, as in real life, in all places, and until it finds whiskey, okay? And one more thing we didn't show is, initially we said that we want also to detect where exactly is the cat, and to track the cat, we could say, which is all this is basically the same as following. So we are going to pull whiskey when he's found. We are going to pull him, and the drone has to follow him. Okay, so okay, this is an ambitious goal. This is putting all that has been programmed, everything is integrated in this demo, and let's see how it goes. Okay, let's see. Good luck, drone. He found the ayo. He found the ayo. He's ignoring it. Yeah. Don't go out. Don't go out. Yeah, drone. Yeah. Let's go. Let's go, drone. Ay, 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 ay. Ah, he almost went out. Almost, almost. Vamos, vamos. Vamos, vamos. Ah, yeah. Great. Let's go. Let's go, let's go. Yeah. That's the time. That's the time. Please, please, please. Please. Find whiskey, please. Find whiskey. Find whiskey. Yes! He found it! He found it! Yeah! Awesome! Awesome! Yeah! He follows him. Yeah! He follows him. Awesome! Yeah! 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 Okay, the final demo worked great. I'm very happy. So we were able to accomplish all the objectives. And okay, well, to watch more conclusions, you please go to the extended version. And okay, I want to thank you for this, and I hope you enjoyed it as much as I did.